There's quite a lot to go through, so I will jump straight into it. Quick overview of the structure of the presentation. I'm going to revisit the changes in the EPBD and the aims of the study. I'm going to discuss briefly characterizing the BACS technology and functions. It'll be very brief. Then the methodology that's been applied in the study, and then the findings from the analysis and savings potential. And as Waide mentioned, at the end of the presentation, we'll have a short Q&A session as well. So the background, as Waide mentioned, the Energy Performance in Buildings Directive, the EPBD, was revised in 2018 and includes a number of additional aspects. That's a set of measures which aim to further improve the energy efficiency of Europe's buildings. It's different to its predecessor because it actually also, for the first time, sort of focuses more strongly on the technical building systems and not just the envelope of the building energy, which affect the building energy performance. And it includes measures that concern the effective control of the technical building system. So the technical building systems are defined as the space heating, space cooling, sanitary hot water, ventilation and lighting. They also include renewable energy generation. And the building automation control systems are also now recognized within this. The predecessor only had rather indirect or ambiguous encouragement to improving building energy performance through better control of technical building systems. But the revised directive has added a number of different measures which help to address this gap in the previous version. To support the whole process of revising the EPBD, an impact assessment was conducted. This was sort of conducted both ahead of and then amended in parallel with the regulatory discussions to inform them. But because it was sort of completed prior to the finalization of the text, it doesn't perfectly reflect all of the final provisions, although it does cover the vast majority. In particular, within this impact assessment, which is available online, there are many aspects which are covered very distinctly, but the parts which were concerning the provisions for building automation control systems were rather glossed over, and hence it's not really possible to distinguish the specific impacts that these are expected to bring. And for this reason, the European BACS Industry Association, UBAC, commissioned my company to do a specific analysis to try to determine these impacts, and this is what I'm reporting on today. The intention is to be able to identify the contribution of the BACS measures independently of the other measures within the revised EPBD, so that their specific relevance to the broader policy objectives can be more transparent. The work started in 2018 and was concluded with the issuance of the report this summer. This is roughly what it looks like, and you can find it on this web link, but I think Leonardo Energy are providing the link as well in relation to this, this webinar. So the major assumptions that are in the analysis are that when we're looking at the impact of the BACS measures, it's presumed or assumed in the study that the member states do fully respect the requirements. And that's in line with how all the other requirements are being or were assessed in the impact assessment to try to determine their impact. It also means that the spirit of their implementation, as well as the minimum legally permissible interpretation, is taken into account, and to support the transposition process regarding how these measures are to be implemented in the member states, UBAC has produced a set of guideline, a guideline document, and so the working hypothesis of this study and the estimates that are derived from it are that these guidelines are respected. Also, there is assumed to be full alignment to the formal impact assessment, so that a priori it's assumed that all changes in the building stock, including the energy systems and how they're used, are exactly identical to those set out in the formal impact assessment. So measures which concern the fabric performance, renovation rates, all of these issues are aligned with what is assumed in the full impact assessment. And this allows the scenarios which look at the effect of BACS to make a direct comparison to other EPBD measures, and hence improves the utility and transparency of them. The guidelines that UBAC developed are available on their site. This is a copy or an image of what they look like here. And for those who want to get details of what is assumed in terms of transposition, they can find that information in here. So I will quickly give a summary of the provisions that concern BACS within the EPBD, but please be aware that this phrasing is not perfect. The proper phrasing is actually in the directive and in the study as well. And there are some nuances which are important, but this is just to try to condense it so we can talk about it in this presentation. So possibly most importantly, they include mandatory requirements for the installation and retrofit of BACS in non-residential buildings, both existing and new, for such buildings which have an effective rated total installed capacity of technical building systems of over 290 kilowatts. And this is to be done by 2025. The measures are actually in the amended articles 14 and 15. There are also some incentives for installation of continuous electronic energy performance monitoring and effective HVAC controls in existing and new family buildings, again within the same two articles. And then there are requirements regarding the installation of individual room temperature controls such as TRVs and independent zone control in new buildings, and alongside the replacement of heat generators in existing buildings within the amended Article 8. Also, non-residential and residential buildings equipped with BACS and electronic monitoring respectively are exempted from physical inspections of heating and air conditioning systems which are otherwise present within the provisions of Articles 14 and 15. So that creates an incentive. Then optimization of performance under typical or average real-life part load operating conditions, including measures such as dynamic or hydraulic balancing. There aren't formal provisions, but there is encouragement towards them mentioned in the recitation. Then there's reinforced requirements with regard to optimizing the performance of TBS inter alia with controls within amended Article 8. And then there is the formal definition of BACS according to the European standards within the amended Article 2. So those are the measures. Now, I'm sure that nearly all of you on this webinar are familiar with what BACS can help to do, but here's a quick summary. They can help to manage the mechanical heating and hot water systems, the mechanical ventilation, and cooling and air conditioning, the natural ventilation systems, the lighting, for example, with timing, occupancy detection, etc. Electrical systems, such as demand management and standby, metering and monitoring, including heat flow meters, communications, safety and security systems, and services to special areas and equipment such as server rooms. And there's many other things which there is a more definitive study in summary rather in the report. They use various hardware. They have sensors, thermostats, humidistats, pressure switches, etc. They have actuators which modulate valves and dampers. They help control zones. They have controllers or outstations which receive signals from the sensors and process them. and they have supervisors which manage the whole system and basically provide the monitoring and interface to users. So some of the benefits of BACS, and there's many other references which can go into this in much more depth, are that they help to improve regulation of indoor conditions and services, and they can reduce energy consumption and running costs. They and particularly can ensure or help ensure equipment only operates when, where, and to the extent it's actually required, hence avoiding unnecessary operation. They can reduce ventilation and cooling requirements that arise when heat producing equipment is used unnecessarily and or when loads are provided unnecessarily because the actual need for ventilation may be less, for example. Then they help to monitor systems and optimize their performance, and they can advise of problems, including not just failure alarms, but alerts to wasteful and unattended operation, and maintenance scheduling. And so they can also help reduce the cost of maintenance. And so these are some of the benefits of BACS. In Europe, as regards the energy performance of BACS, there is a standard called EN 15232, which includes a lot of different elements, but it has a detailed list of the control, building automation, and technical building management functions which have an impact on building energy performance. And if you want to get a good insight into the types of things which are being considered in this analysis, then that's a very good reference. It sets out a methodology to enable definition of minimum requirements regarding the control to be implemented in buildings of different complexities, has detailed methods to assess the impact of these functions, and a simplified method to get a first estimate of the impact of these functions on the energy performance of typical buildings. And it's this last part that we make quite a bit of use of in this analysis. Here's a breakdown of the space heating services that are treated in 15232. So it breaks the heating systems down into these different elements, so the control, emission control, thermoactive building systems, emissions control, control of distribution network, hot water temperature supply return, control of distribution pumps in networks, intermittent control of emission and or distribution, the heat generator control for combustion and district heating, heat generator control for heat pumps, etc. Sequencing of the generators, the control of thermal energy storage, and so forth. And it works through every single technical building system that I mentioned earlier, and has a similar breakdown of different types of configurations and strategies which can apply to their control, and also a section which deals with the overall supervision and monitoring of control across all technical building systems. Within it, it actually defines a set of energy performance classes that classify the energy impact from less to more sophisticated BACS solutions, and groups them into classes ranked from Class D, which is the least efficient, to Class A, which is the most energy efficient solution. And it does this for each type of technical building system, and all of the possible, or the principal configurations which can be found among them. It is then actually developed so-called BACS factors, which are the result of a great many detailed building simulations to analyze the impact of using any one different type of BACS solution on these technical building systems from the energy performance perspective. And the BACS factors themselves, which are linked to these classes, D, C, B, and A, show how the relative energy consumption of a given technical building system combination with a particular building type, because it distinguishes by building types, will vary as a function of the BACS energy performance class, where C is the reference. And those factors are what we make use of in this study to estimate the impacts of policy measures which can cause a shift in the efficiency class of BACS that are installed in buildings. So in terms of the modeling exercise, a very detailed simulation model has been developed to model the entire EU building stock. It essentially makes use of a vast array of data, which I'll mention a bit more in a minute. It divides the stock into 3 regions, so EU West, South and North. And then with each region, it breaks the building stock down into all the different types of building stock, and then within that, all the different technical building systems which supply that building stock and the energy consumption associated with them. And it overlays on that the distribution of BACS class when BACS are present from D to A per building type and per technical building system. And then it models the evolutions of those over time. So roughly speaking, if you look at this grouping, which is drawn from the impact assessment, in place of the 5 regions that are here, the EU South region that we treat is the combination of the yellow and the red. The West region is the green countries shown here, and the North is the combination of the purple and the blue. The breakdown by building types that are simulated in the model are single-family homes, multifamily residences, offices, retail outlets, education establishments, healthcare buildings, hospitality buildings, and other buildings. And that aligns it to various data sources that are available, most particularly those used within the impact assessment and in the EU's Building Stock Observatory. But we also take a lot of data from other BACS studies and sources, including these ones shown in this list. In doing this, we assemble and organize the data on the existing EU building stock, a priori making use of the EU Building Stock Observatory data, which is the reference that's used in the impact assessment. And that shows a lot of this kind of breakdown, not the BACS class, but many of the other aspects, including floor areas and energy consumption per meter squared, figures, etc. For each type of building stock, each country, going back through time to the present. And then in the formal impact assessment, that data was projected forward using a various set of assumptions. And we essentially aligned to those assumptions in this. And so the BACS part apart, we would produce exactly the same results as the impact assessment did in the formal impact assessment for the EPBD. Now, to understand better, some of the previous references I mentioned there have already got quite a bit of information about the data that's available on the breakdown of BACS solutions by BACS class, by building type and region in the EU. But we complemented it in this study by doing a survey of UBACS members to derive the best estimates of the current distribution of the BACS classes by technical building systems and building type across the EU. And the outcome of that survey were pretty consistent with the sort of net results which are reported in the other studies. And so it seemed to be a reasonably reliable starting point for the snapshot of the breakdown of the BACS classes across the building stock and by region. Of course, there are many uncertainties, and it's not exactly it's by far from the final word on this topic. But it's an improvement to what's been available previously, and so we hope it's a kind of useful contribution to the literature and analysis that's available. With also a previous work that I've been involved in has noted that there are rules of thumb that can be derived which help gauge likely evolutions for BACS markets. For example, you can see the regression analysis shown here of the expenditure on BACS per capita as a function of average GDP per capita, and where particular economies sit above and below that progression line at that moment in time. And these sorts of analyses can be useful for deriving trends under a kind of business as usual case, where you would assume working assumptions about evolution of GDP and other factors which can contribute to driving the market forward. The scenarios that we considered, where there is the fully in line with the EPD. I say two scenarios, but it's really three. We have the EPBD compliance scenario, which is essentially what's known as the agreed amendment scenario in the EPBD impact assessment. And so, including the BACS measures, then the revised EPBD would actually be expected to follow this EPBD compliant scenario. We also derive a EPBD compliant, but without the BACS scenario, which is a bit of a tautology because it can't be compliant if it doesn't include the BACS measures. But it's compliant in every other regard apart from the BACS measures. And in the case of BACS under that scenario, a kind of business as usual is assumed that's in line with other types of analysis. I'll discuss that a little bit more in a minute. And then finally, just as a reference point, we also did a scenario which looked at what would happen were everything to be compliant with the EPBD, with the agreed amendment scenario, except for the efficiency of BACS is completely frozen. It doesn't change over time. And that provides a kind of an implausible but helpful reference point. When we're mapping the EPBD BACS measures to the BACS installation and replacement events, we use the same assumptions that are within the impact assessment regarding the frequency of trigger events which can happen. So in an ordinary progression, BACS could be installed whenever there is a new construction event, such as a new build or major renovation project, whenever a technical building system is renewed or replaced, or as an add-on or improvement to existing control systems. In case A, in European building stock, you would always expect BACS to be installed in some form. The efficiency class is another matter, but you would always expect BACS to be there. In case B, this will often produce a renewal of BACS, at least with regard to the part of the BACS which control the technical building system in question. And in case C is the part where there's the least likelihood of occurrence and of change in BACS through that process. So the methodology which is applied simulates the expected response with regards to BACS performance at each of these trigger events under the scenarios. So for the EPBD compliant scenario, it's assumed that the BACS measures are fully respected and implemented in line with the UBAC guidelines. For the compliant with frozen BACS, it's assumed there are no changes in BACS performance with each of those trigger events. And for the compliant without BACS scenario, it's assumed that the BACS progress in line with the business as usual trend. And that's consistent with previous EU studies, for example, the case that's assumed in the Smart Readiness Indicator technical study. We should also mention that the EPBD measures do actually accelerate the trigger events for non-residential buildings with greater than 290 kilowatts of installed capacity. So that's also treated and taken into account. And just to give you some illustrations of what happens, with the compliant but no BACS scenario, in other words, where there are no BACS measures in the EPBD, but they just evolve in line with a business as usual trend, then the model projects this evolution of BACS class by single family homes in the Western region. And you can see, for example, that BACS are projected, Class A are projected to be 0.5% by 2020 and just under 11% by 2050. Class B, 21% by 2050. And Class C to be the dominant one in 2020 of about 78%, declining down to about 58% by 2050. In the looking at how that would be expected to evolve in the fully EPBD compliant scenario, in other words, including the BACS measures, then it's projected in the modeling exercise that the class B becomes the most dominant with about 53% by 2050, and that the class A is also very significant with about just under 29% by that time. But there are still some proportion of C and D and no BACS in the stock in that time. Here we can see the total final consumption, energy consumption by building type in terawatt hours under for the EU building stock that's projected in the formal impact assessment under the energy performance in buildings compliance scenario. So in other words, it's equivalent to the agreed amendment scenario in the formal impact assessment, and this is the breakdown by building type. Shown here is essentially the same trend, which is the blue line at the bottom, but the two above it are the results which should be expected for the two other scenarios. So the grey line is the frozen BACS scenario, and the orange line is the EPBD compliant with no BACS measures scenario. So the difference between the blue and the orange is essentially what this study estimates is the impact of the measures if they are properly respected within the EPBD. And when we project this into savings by building type over time, when comparing those two scenarios, then what we see is that the total final energy consumption savings peak at about 450 terawatt hours a year by 2035, and then decline slightly thereafter because as the business as usual trend starts to catch up with the measures that are in the directive. Just as a point of comparison, you can see how that varies with the frozen BACS scenario shown here. In that case, instead of 450 terawatt hours by 2035, the savings reach about 650 terawatt hours by 2040. So there's a roughly, the business as usual, therefore, is assuming roughly a third of the benefits of what would be expected from the EPBD measures. When we look at this in percentage primary energy terms, and this is important because up to now we've been assuming that all the provisions in the EPBD are respected, and hence the results overall for building energy consumption are in line with the impact assessment. But that may or may not be the case. And what is a more robust aspect is to look at the percentage savings, which even if fabric measures are not delivered as expected in the impact assessment, these kind of percentage savings from the BACS measures would still be expected were they to be implemented. And so overall, we're seeing roughly just over 14% savings in primary energy due to the BACS measures from within the analysis we've looked at. And when we break these down by types, building type, into fuel type as well, not surprisingly, we can see that the savings are least significant for the electrical end uses because the BACS measures that are envisaged have least significance for those, and hence they're more significant for thermal energy usage. And on the other hand, they are also much more significant for the non-residential sector as a percentage term than they are for the residential. And again, this is because there are mandatory measures for the non-residential sector which have to be respected by a certain time, by 2025. Looking at CO2 savings, there's a slightly sharper tail off in these, but that's really because the emissions factors are assumed to decline for thermal, for the primary energy systems in the EU's building stock over time. But we see that the total emission savings from the measures compared to the the EPBD compliant scenario are expected to be about 65 million tons of CO2 by 2030. The investments are also simulated, and they peak at about 7.5 billion in annual investments by 2022, and then they decline after 2025 as the mandatory measures for the non-residential sector have already been implemented. And then yeah, there are still measures, but those are the parts which concern the greater than 290 kilowatts of installed capacity. And there are still measures which continue for the whole building stock thereafter, but they're obviously less dramatic drivers of investment. And so, hence the total incremental investment declines. But the energy bills savings due to these measures are considerably larger, and this is the projected savings here, again using assumptions which are fully in line with the price of energy with the impact assessment for the EPBD. So instead of a peak of on the previous investments around 7.5 billion, here we see a peak in savings, the value of energy bill savings of over 37 billion euros by 2034. So just in summary, the revised EPBD can be considered to be the first time the EU has applied rather holistic policy measures to promote energy savings from BACS. And the aim of the study was to model the impact of these provisions and to determine what component that the BACS measures will be expected to deliver, assuming they are fully respected. It's intended to, the work was intended to complement the findings from the broader revised EPBD impact assessment, which did not explicitly address the energy savings and other impacts related exclusively to BACS policy measures. And what's found is that if fully respected, the BACS measures could be expected to produce very substantial energy savings in the building stock of the order of 14% of the primary energy consumption. And the value of the savings which would be attained would be approximately 9 times the cost of the investments required, and hence be highly cost effective. As a broad view, but this is not modeled as simply as this, this is roughly consistent with an evolution over time to an average BACS class of B. So given that, and we know that Class A produces significantly greater savings than Class B, there is still scope to save above and beyond these measures, and they could be roughly doubled again were Class A to be achieved over this time horizon. So that's it from me for this presentation. I'll now hand it back to Diderot, and I'm somewhat surprised to see that we're actually doing quite well on time, so we have a little bit of time for Q&A, I hope.
Indeed, thank you very much, Paul, for this presentation. Very nice overview. And maybe before we dive into the questions, we also have Simone Alessandri as a participant. Simone is Director Governmental Relations for the EU BAC, for the European Building Automation and Controls Association. And because you already mentioned that your study is kind of assuming implementation in member states according to what has been put forward, for instance, in the guidelines published by EU BAC, I think it's good to let Simone comment a bit on how we are on this transposition. So just bear with me, and I'll try if we can get Simone online. Okay, Simone, you should be able to talk.
Thank you, Diderot. Can you hear me?
Okay. Yes, we can. So
perfect.
Welcome, okay. Simone, and nice to have you here again.
Good afternoon, everyone. Thank you, Diderot. Thank you very much also to Paul for making yourself available despite your busy agenda. Thank you to Diderot and to Riva for organizing this. I would like just to make some comments on on the implementation. So we, as you mentioned, the EPBD has a deadline for transposition in March 2020. So it's only 3 months from now, and as EUBAC, we are trying to keep track of what's going on, and we would like to highlight the fact that these results, these impressive results displayed by Paul, are achievable only with high degree of ambition in the transposition. So I would like to highlight the fact that in some of the provisions of the EPBD, some of these provisions actually have a certain degree of subsidiarity that is given to member states. So it is true that the main legislative framework is set, but it's also true that there is the importance for stakeholders to have exchange of views, and to also for have a certain push, I believe, on the legislators at national level, so that that a certain degree of ambition can be achieved, and those results can be achieved, especially now that we are all talking about the Green Deal and hiring the ambition on these topics. So I would like to mention that in the mandatory requirements for BACS, so both in Article 8 and Article 14, so meaning both for the installation of the so-called self-regulating devices and for the building automation and control system in non-residential buildings, both existing and new ones, in the text there is written where technically and economically feasible. So I would like to highlight the attention on these words, because the definition of technical and economical feasibility is made by member states in their legislation. So it's important to mention that the Commission released guidelines on the implementation, and they specifically say, and I'm quoting here, note that is for member state to detail in which specific cases meeting the requirements is not feasible from a technical, economic, and/or functional perspective. Member states should ensure that these cases are clearly identified, framed, and justified. So since we are seeing some drafts in some member states where this is not happening, I would like just to highlight the fact that if the member states in their legislations, they still talk about where technically and economically feasible, then we end up with a big risk. And the risk is that basically in each case, in each specific case, the single assessor or other persons can say that in that case it's not feasible without further justification. This is not a proper implementation, and this will not achieve the potential that was displayed by Paul Waide. So yeah, I just need to I wanted to highlight the attention on this, to work together on these different principles can be used. So the member states in their pieces of legislation, they can put, for example, the initial costs of BACS. So they can put a threshold on the initial costs. So maximum, I don't know, 50 euros per square meter, or whatever is the figure that they would like to use, but a parameter must be included. And same for the payback time. So another parameter that is mentioned also as a possibility in the text of the Commission guidance is that they put, for example, it is deemed feasible as long as the installation of BACS, the payback of the installation of BACS is less than 7 years, for example. So yeah, I just wanted to highlight this point and the importance to follow the transposition for all the stakeholders in order to unleash the potential as per the evidence showed by Paul in the study.
Okay, thanks a lot, Simone, for this intervention and clarification. And I can only invite participants to go to your website, so eubac.org, and there indeed you can find as well as the study of Paul Waide, but also the guidelines putting forward and elaborating on this element of feasibility. So
yes, just the guidelines are also available in French and German, so not only English. So you will find everything on eubac.org.